So as we had our previous class, we managed to focus on the definite integral. That was the last part that we had. And on that class, we had to focus on the application of the limits. And as I defined on that part to say the definite integral is definitely the one that we are going to need when we have got the limits taken from A to B, our lower limit and our upper limit. So when we integrate this, obtain our f of x, you are going to substitute those limits, all right? Where our limits, we're going to have to substitute upper limit minus the lower limit, which simply means f of b minus f of a. This is the same application actually that we are going to use on our areas. So as you have, guys, as you have understood your integrals from the standard functions, as I explained, and also knowing the definite integral, this part is going now to help you to calculate the area. So we are going to have different methods, the strip method and the definite integral, whereby actually that's the basic method that you're going to have in our syllabus, where we are saying, all right, let me present this way, our strip method. So it's just nothing, guys. It's nothing. Area is nothing, guys. All right. And the definite integral. And the definite integral, as I just explained here, guys, on our part of the definite integrals. We can consider that a function or a graph can be drawn. So what you just need is that any area can be divided into very thin strips. And the total area is simply the sum of areas that gonna be generated, that are being generated on that function or the given graph, bounded by a certain graph. All right, bounded a certain axis. Is it the x-axis or the y-axis? So let's say we've got something like this graph that is being drawn. So you can have our function in this manner. All right. So you have drawn your function. This is your f of x, whether we are having any presentation there for our f of x. So it will be taken from a certain point to a certain point. So let's say it is between, let's say we're taking this area between our points A and B. All right. This is A and B, which are the limits where the area is being limited to. They're saying this must be taken from A to point B. A and B, these are your limits, as you had when you're dealing with what? Your definite integrals. So the strip that we're talking about, the representative strip, is the one that our area is going to be calculated with respect to. So if we are calculating with respect to, the limits here are for what? X. These are X values. So it means our representative strip is going to be for X. It's going to be for the X values, that is with respect to X. So this is just with respect to X, meaning to say dx. This is just like dx with respect to x. Remember when you had this concept with respect to, if it was the area that was calculated, let's say we had something like this, guys. All right, let's say we have got something of this nature, which is gonna be basically of your N5 stuff. You can have a function like this. Let's say you've got our limits. In this case, there will be C and D, but the strip, because the limits are for Y, it means the representative strip that we have is for Y like this. So it means we're gonna integrate with respect to Y. With respect to Y. So the strip is for X, or the limits are for X. It means the area can be calculated from there. So guys, without wasting our time, the area can be calculated because Y here is representing f of X. we can have our area as the integral of y with respect to x, where our limits are being taken from A to B, where that area is calculated. So this is the area with respect to x. With respect to x. So y there represents what? Function of x. So meaning to say we can write this as integral of what? F of x. It's a function of x, y there. It's a function of x that you're supposed to integrate with respect to x. So if it was a condition that the strip is for y like this, it means this function is of x, which is equal to f of y. So as I find the area with respect to that y that you are given, it's going to be what? Integral, having our limits, like I said, this time it's going to be from C to what? From C to D. So that's x that we are talking about. But the strip is for y, the limits are for y. So it's with respect to what? With respect to y. These limits are for y. So x is what? F of what? F of y, the function of y there. So that is, we can have our area using this formula if it is for what? If it is for the y. So read, understand the question that you're given. Where is it taken from? 2. All right. So in our normal consideration, we just see this formula because we are just given for the x values. Not to say we cannot have this condition, but mostly we are just having for what? For the x values. So how do we calculate this area? We just need to know the sketch where the area is being taken from. So definitely in this part or in this topic, you must be able to know how to sketch your graphs. All right, the sketching of what? Of graphs. So know how to sketch your graphs. We're not going to talk about that. We're going to simply go straight to the questions, how they might be given. So you'll be given a certain interval for that sketch that you're being asked to calculate the area. So I'm just going to model a question here that we're going to use. We try to work with that. Then we apply our standard integrals. So, all right, let us just use this example that we are given. So what we need is to sketch the graph of, all right, so sketch the graph of y is equal to 4e to the exponent of x. All right, so that is what we are given. Then shade the area bounded by the graph, the x-axis. All right, so let me just write this one, shade the region. So it is, you just have to work with the condition that you're given, guys. All right. So share the area, not like the region, but the area. All right. Bounded by area bounded by the graph. So these are the conditions now that you're given. So it's by the graph, comma, the x-axis, the y-axis. So we must consider all these conditions, and x is equal to 3. So these are the conditions. Then show the strip and calculate the area. All right. So show elementary strip. Elementary strip and calculate. So our question here, and calculate the magnitude of the area. So this is the magnitude, and calculate the magnitude of the area. So this is what we are given there. This is what we have. So what is it that we are supposed to consider? Like I said, we need also to understand the basics of sketching of our graphs. So here's just a sketch. Remember, when working with an exponential function, y is equal to a to the exponent of x. That's an exponential function. if we are given this as a positive, like let's just say y is equal to k a to the exponent of x like this. So k is positive and also our x is positive. It means in that manner, we are going to have our function like this. If, let's say, the exponent there was a negative, because we can have it with a negative exponent. So we can have it now in that other manner. A negative exponent will be just like this. So it will be reverse. It can have a negative value, sorry, a negative exponent, negative k. A negative exponent will be just like this. It will oppose this one, not negative k. This one like this. But for a negative k, this one, let's say k is negative, it will just go that way when our k is what? Is negative. So it's going to be like this. Another one. So these are for negative k, but the exponents there being positive as they are, but they are now in the negative region, like we are opposing. So it's just a reflection of the graph that you are given of e to the exponent, of a to the exponent of x. So you just have to reflect your graphs depending with what you're given. So this part, can we go through the sketching of what? Of our functions. So e to the exponent of x, this one, it is a direct function, guys. If you're given this from our graphs, all right, we do understand we are going to have our sketch like this. So this is e to the exponent of what? E to the exponent of x. So where we have the 0 there, that is the major part on our origin. For the value of x, when it is a 0 there, we're going to have 4 e to the exponent of 0, which is what? 4 times 1, which is 4. So our graph is going to be crossing the y-axis at what? At 4. This is the major point. The shape, we know the shape is going to be the same, guys, for all these exponential functions, as long as it is a positive exponent. So we are going to have our graph in that manner. So it will be increasing in x. So the sketch, guys, you need to know each and every type, guys, from your N3. Remember, you've been drawing those functions. Now you just need to sketch direct. So this is our graph of what? Y is equal to 4a to the exponent of x. Limited, now they are saying, according to this information, shade the area bounded by the graph. This is our graph. So once something that is bounded by this graph, the x-axis, so it's bounded by the graph. Take note, the x-axis, meaning also the x-axis is considered. Then they did not stop there. The y-axis also has to be considered, and x is equal to 3. The line of x is equal to 3 is a vertical line like this. This is the line of x is equal to 3. So which region is going to be bounded? You're going to see the region bounded is going to be here. In between, they're saying it must be bounded. It is supposed to be covered by these graphs or these lines that we are given, everything that we are given there. So we need the line of x is equal to 3. The line of x is equal to 3, guys, is that that's simply a vertical line that we are considering there. All right, so I'm just going to indicate a vertical line. It's just a vertical line, that one. X is equal to 3. So let's say this is where we are having our line of what? X is equal to 3. Something like this. This is the line x is equal to 3. Meaning to say, where it crosses the x-axis, x is 3. So with this information that we are given, bounded by this graph, the x-axis, the y-axis, and this line, you see it is the region here in between that was going to remain, that is bounded here in between. Here, this one. This is the region they are talking about. So we are supposed to calculate the area in between. So look in the area that is here in between, this area, this one, this region. where are we having the limits? The limits are there, this one and this one for x. So it means we are going to have our strip for x. The strip represents the limits that you are going to be having there. The limits are for x, so the strip is for x. So it means we are calculating our area with respect to x. The strip is for x, these limits that we have for x. So it means our area to be calculated is for x. So they say the shade, the region, what was, so in the question, you just answer according to what they say. They said you're supposed to shade that region where we are going to have our area, this region. So we shaded. Then after that, we are supposed to calculate that area. So this is where we are saying the area with respect to x is what? The integral of y with respect to x, our strip taken from A to B, which are the limits covered for x, the x values that we are given there. So that is the content of your area, guys, just like that. So you were going to substitute. Remember, the y that we're talking about here is the function of what? Of x. So that is, okay, our limits from 0 to what? From 0 to 3. So y there is what? 4e to the exponent of x with respect to x, like that. So this is our condition with respect to x. So we integrate. Guys, it's the only thing there is on the sketch. The rest, guys, is your integration. So from there, you integrate. Remember your integration dealing with what? A standard function. This one is a standard function, e to the exponent of x. So we can take our constant outside and integrate e. As we do understand, guys, integrating e to the exponent of x, I said it remains as it is. So in that case, we were not going to have any problem, and that's it. Remember the definite integral concept. You substitute upper limit minus the lower limit in place of x. So that's 4 e to the exponent of, in place of x, that's 3, minus 4e to the exponent of 0, like this. So this is the condition. You can evaluate direct as it is. You can simplify stage by stage. It's up to you. So here simplifying the first part, I'm just going to round off to 3 decimal places. So let's fix our calculators to 3 decimal places. All right, so that's 4. The E is on lean. So it's a shift. You press the lean button there. You will see E to the exponent of. So you press 3 there. All right, so that is it. We were going to have 80, 342. So that's 80, 342 minus 4e to the exponent of 0. Remember, any number to the exponent of 0 is 1. So 1 times 4 is what? Is 4. Or you can just use your calculator, guys. Sorry for that. So that is in place of that, put a 0 like this. So that is going to give us a 4. So remember, it's because we fixed to 3 decimal places. What we just need there is what? The 4 there. Just like that. So we're going to subtract. So what is the difference between these two? Let's see, 80 is just like 80 minus what? It's just like 80 minus 4. 80 minus 4 is what? 76. So that's 76, 342. So this is area. Area is measured in square meters, square centimeters, square kilometers, square millimeters. But here, what can we say? Are these meters? Are these centimeters? We do not even know. So we use the square unit concept. We know the area is measured in what? Square of that unit. If it is millimeters, you're going to have square. If it is kilometers, you're going to have the square of it. So that's why we write unit squared. That unit that you're given, you're supposed to square it to represent that you are working with what? You are working with area. So this is the content of your area, guys. Just sketch the graph. So as long you know how to sketch the graph. So the problem now that I'm seeing is that we did not work with that sketching of graphs. And someone was asking on membership that, can you have an introduction on how to sketch these graphs? So guys, issue of time, time is always something when it comes to learning, but we shall try by all means to work in as much as we can gonna try by all means. But that is the condition. We just need to know how to sketch our graphs, know the basics of your function, a parabola, an exponential function, those trigonometric function, the sine, the graph of a cos, know all those functions, guys, all right? So we need the basics of how to sketch our functions. So sometimes we can be given a condition where the two graphs or the curves where part whereby we've got the curves where part lies above and apart, another one lies below the x-axis. There can be a condition like that, whereby you are simplifying. Let us say you have got a condition like this. You have a certain function that you have drawn, and it is just like this one. All right, just of this nature, where if we are to consider our function in this case, if we are to consider this function, there is a section that is above the x-axis. All right, there's a section which is above, which lies above x-axis. There's a section which lies below x-axis. So this is the condition that I'm gonna explain about. So these are curves where a piece of that curve lies above, all right, lies above, and another piece lies below x-axis, lies below the x-axis. So how do we treat such functions where a certain piece is found above on top, another piece is found below? If we were to calculate this area, let's say we've got our limits. In this case, this is A, this is B, all right, and this is C, as we are having a continuation from A to B and to C. So it depends, like on your presentation, someone can start this one and say this is C to D. All right, it's up to you guys. Here I'm just gonna have a continuation to say I've started from A to B, and another part is gonna from what? From B to C. It's a continuation, the same limit that we had. We cannot say this one is now C. This one. Yes, we can write it that way, guys. It's textbooks, guys. They just want you to get confused. At the end of the day, we need to know the basics, how to answer our questions at the end of the day. All right. So when we are given this condition, you are going to notice that you are going to integrate this function. As we said, we're going to have an integral. And as you integrate, you'll be having the limits applied on this part. Let's say it is below this one. There's an area there. This area that you're going to calculate, you're going to notice that it was going to give you a positive value. This one in the below region, as you calculate it, you are going to notice that you are going to get a negative area, a negative value of area. Here, a positive value of area. So you had integrated. So it is just you integrate. Remember your area, guys, as we had the previous case, our area with respect to x. So it's gonna be what? You integrate, you're gonna integrate that function, f of x with respect to what? With respect to x from A up to C. So from A up to C, guys, it means what? We're gonna work with A up to B first. It's an area on its own, this one, that has to be applied its limits from A up to B. All right? Then there is another one which is on another region, this one, from B to C. It's another region. We were going to subtract that one. Why are we subtracting? Remember, on top, it's positive. This one, it's negative. So if we subtract, it means we are going to add them at the end. Negative, negative, it's plus. So it's simply this area plus this area. But if you just combine it like this to say, all right, area 1, let's say the area here is 5 square units, and this one it's negative 5 square units. You just say, all right, it's area, I'm going to add 5 plus minus 5, you get a 0. So you're supposed to subtract so that minus and minus will add those areas. 5 plus 5, you get 10 square units. So you have to subtract the area, the other piece from B to C. So our limits now, it's B to what? To C. Of that same function, guys, that you have been what? That you have been dealing with, that you have been integrating. It is only that we are saying we are starting from A to B, then from B to C. So this is our condition. So some they can say this one, they take them as A and B. Then from here, they use C and D. Is the same thing where B is simply representing the same point as what? As C. Depends with your understanding. But this is what you're supposed to have. So this is negative in value. This is what? Positive in value. You're supposed to remember that. So it's a condition that you're supposed to have when one part is above and another one is what? Is below. So I just thought, guys, we're gonna like have like a lot of questions or a lot of part that we can work with in our presentation. But it seems like our time also this and that. So we are going to try by all means in our next classes to work out as many questions as we can. So I'm just gonna put maybe one example, and from that example we try to figure out how to apply this concept where one section is above and another section is below. So always sketch the function so that you can properly see that this piece is below or it is not. Always sketch your graphs. All right, so let me have it here. So like I said, because there's another part where we've got two functions, so we are going to have that as another class. We're going to add that one again. So we still have a lot of classes, guys, that has to be done. But anyways, let's see. Here, we're going to consider this one as our question sketch. All right, so we're going to sketch the graph. Sketch the graph of y is equal to x squared minus 6x plus 5 like this. All right, then shade the region bounded just like the previous case that we had. All right, let us shade the region. Shade the... all right, no problem. I don't know why like I read this question the way I want, but I'm forgetting that I'm using another source. So anyways, let me take the way that they are asking this question. All right, so this is bounded by the graph, the x-axis. All right, the x-axis, the line of x is equal to 7 and x is equal to 3. All right, no problem. So that is our part there. Then show the representative strips. All right, why are they saying strips? The representative strips. It simply means that there's something there. There's something here. And calculate. And calculate the magnitude of what? The area. The magnitude of area. All right, the magnitude of the area. This is our question. Why are they saying show the representative strips? It is a condition that we are simply seeing here to say that there is a region here that is on its own, another region. So it means there was going to be a strip, this one. It means there are two areas when it's like that. Because here it is representing the representative strip for X, which is the same thing here, guys. It does not mean that the strip has changed, but we are just saying Here it's a certain area on its own. Here it's a certain area on its own. So it will be like, here we've got a strip, there's a strip. Guys, do not even worry about that one. All right. So this is our question here. We are given to sketch this graph. This is a parabola, as we have, remember, as you work with a parabola, guys, one, we have to consider. All right, let's sketch, because this part of the sketch, guys, is something else. But from your N3, guys, we talked about this, but not like as a separate topic. It was just part of, I don't know, but I'm going to work with this separate topic, guys, on its own. Do not worry. Do not worry. But we don't have days, guys. Now time is limited. Anyways, let's see. Our graph is given as y is equal to x squared minus 6x plus 5. So as we have a parabola, we need the x-intercept, y-intercept, a lot of things, all right? But not to say it's a lot, but just, okay. So the y-intercept is on a condition that x must be 0 for us to have the y-intercept. So when x is equal to 0, you're going to substitute in place of x, y is equal to 0 squared minus 6 times 0 plus what? Plus 5. That is what you're going to have. So you're going to see that y there was going to be what? Positive 5. That's the y-intercept. When x is equal to 0, y is what? Y is 5. You're going to do the same thing for the x-intercepts, this and that. For the x-intercepts, you have to solve now for these x-intercepts, all right? So for the x-intercepts, y is equal to 0. It means this whole function is equal to 0. X squared minus 6x plus 5. All right, another one was asking me, like, why don't we calculate, like, on this last question that we had, it's only that I removed, it was an exponential. Why didn't we calculate the maximum turning point on an exponential function? You don't calculate those things, guys. They are for a parabola and for those cubic functions. On exponential functions, just the sketch, there's no maximum turning point there or minimum turning point, all right? So if you are listening to this one who asked that question, I think I've answered you there. So this is it. We are going to find our x values. We can just use factorization. As we can see, the coefficient of x squared is 1. So I'm just going to have 2 brackets, x here and x here. What are the factors of what? Positive 5. So I'm considering the factors or the products of what? A positive 5, which must add up to negative 6. So which products, guys, or factors there? Positive 5. So that's positive 5 and positive 1 is going to give us a positive 5. But when we add this, what are we going to have? A positive 6, not a negative. We need a negative 6. So we are supposed to just put a negative like this. Negative 5, negative 1. Negative times negative, that's a positive. If we add these two, you get a negative 6. So these are the ones that we need. Negative 5, negative 1. So meaning to say x is equal to what? 5, or x is equal to 1. Remember, you throw these ones to the other side of the equation. So we have our x values. These are the x-intercepts, all right? So we have our x-intercepts in that case. All right, no problem, guys. We're going to need this on the sketching. So our x-intercepts, that x is equal to 5 or x is equal to 1. X is equal to what? X is equal to 5. All right, let's put them aside like that. We move on. It's a parabola. We can also like just try to understand the turning point. All right, let's talk about the shape first. Y is equal to 1x squared. The coefficient of x squared is positive. Remember, if you are given y is equal to ax squared plus bx plus c, a is of the shape. If a is greater than 0, a positive, we are going to have a smiley shape like this. For a which is less than 0, we are going to have a sad shape like this one. So in our case, that's a positive. So you're going to have this shape, a smiley shape. So that is for the shape, this one. All right, it's for the shape. So the issue of the turning points is another part that you can use to say for the turning points. I said, if you are calculating the turning points, yes, you can use at the turning point, x is equal to minus b over 2a. Yes, it's fine. You can use that formula, or you can simply use this condition. At the turning point, x is equal to the average of the x-intercepts. So you just add these values. It is the average. Average meaning say I add 1 plus 5 over 2, which is what's 3. 6 over 2, that's a 3. So this is the x at what? At the turning point. So therefore, what is our turning point? If x at the turning point is 3, what about the y value? We need to substitute in place of what? X into the original function. This is x squared. So this is 3 squared minus 6 into 3, but it's not important. It's not important to show the turning point that's negative 4 when we are sketching like for this question. Yes, when it is a question that is asking you to sketch a parabola or to draw a parabola, you must show that one. But for this question, it is not important, the turning point, all right? So anyways, it's just for the sake of revision, guys. Remember, like I said, on our sketch, what are we going to need are these. These are the most important things. So let's try to figure out how was it going to look like, how this function was gonna look like, all right? So as we can see, we were going to have our x-axis and y-axis like this. So this is our x, and this is our y there from 0 going, whatever that we are having, that's -1. And on this side, you're going to be having 1, 2, 3, 4, 5, 6, 7, and so on and so on. We need 7 there on x. Remember, the bigger value there is 7. So 7 must be there. All right, no problem. 7 is there. X3, 3 is also there. So make sure that the values that are given for x are also presented. For the y values, there we're just going to write the maximum is 5. I mean, for the bigger value there, this is the minimum value, the turning point. So it's just going to be -1, -2, -3, -4, something like that. Then we've got 1, 2, 3, 4, 5, and so on going up. All right, so this is just a sketch, guys. Do not panic about this. So you're going to indicate remember your shape, you already know. So what is important is what? The y-intercept, which is 0, 5. This graph is going to pass at 0, 5. So guys, even on a sketch, these values are not even important. As long you know it's going to be like this, that is what is the importance there, guys. This one of trying to be, yes, it is for the sake of you to have exact thing of what you are having. If you know these functions, like you are revising them now and again, you end up doing these direct guys without even like labeling like this. All right, no problem. But this one was important. The x values are at what? 1 and 5. These are the x-intercepts. Remember, y-intercept, then x-intercept 1 and 5. So these are x-intercept 1 and what? And 5. So our graph was going to be drawn like this. Remember the shape. So it was going to be like that. But as it is like that, there's a turning point. Remember at what? At 3, -4. There's a turning point there. 3, -4, maybe somewhere there. 3, -4. So our function was going to be, we do not know where it is coming from. It goes like this. We do not know where it is coming from. It is there to the what? To this point at 1. Goes to the what? To the turning point. It turns. Then it goes up. All right, the turning point, it turns, it goes up to pass through the what? The x-intercept. Then what does it do? It goes up. We do not even know where it's going to end as it is going up there. This was supposed to be our function. The graph of what? Y is equal to x squared minus 6x plus 5. All right, this is what we're supposed to have. But because we are given conditions where the area is going to be calculated, what are those? Let's talk about those conditions, all right? This one is just our turning point, not important. So here they are saying the area to be calculated is supposed to be bounded, covered by that. What is it supposed to cover this? The graph, which is the one that we drew, this one, is supposed to be bounded by this graph, all right? The x-axis, so we have our graph, this one, supposed to be bounded by this graph. The x-axis, all right? There is a line, x is equal to 7. Remember, there's a vertical line there, x is equal to 7, x is equal to 3, x is equal to 3, like this. So you're going to notice that the area they're talking about is this region and this region here. There are two regions, one below the x-axis and another one is going to be above the x-axis. All right, let me remove this and see properly. So we have the line of what? X is equal to 7, which is needed here. X is equal to 7. Remember, I said we're going to need this line. X is equal to 7. So definitely you were going to draw a vertical line to represent the line of what? Of x is equal to 7. Another one for what? For x is equal to 3. These lines are being given there. So in between these regions, we're going to notice that what is bounded, where we see the graph is there, the x-axis is there, the line of x is equal to 3 is there. It was going to be this piece. We're going to talk about it. And also, we're going to talk about this piece, which is above the x-axis, this one. So these are the conditions that we are talking about. So as we have this function, we can see that on this part of our function, there's a region on top and there's a region below. So this is what we have been talking about, guys, on this function of ours. The limits are for what? For x. As you can see, these are the limits from 3 to what? To 5. Then from 5 to 7. So this one, it has its own limits. It has got its own limits here. The strip is for x. Yes, this one also, the strip is for x, but from 3 to what? From 3 to 5. And this one from 5 to 7. So as I said, any region above the x-axis, as we see it like this, it's on top of the x-axis, it will have a positive area. Any region below the x-axis will have a negative area. So if we calculate, this is exactly what we are going to notice. So there are two areas there that we can see. There are two regions, meaning to say we are going to calculate two areas. All right? So this is the condition of our question, just like that. All right, so as we have our question here, we are going to notice, like I said, there are two of them. So we're going to call this area 1. All right, so this will be our area 1 and this will be our area 2. So this one is going to be what is representing our first area, this one. And this is going to be what is representing the second area. So as we can see, the second area is what is positive because it's on top. So as of our formula, as we saw here, what is on top is positive, below it's negative. So here it's positive minus the negative. So it simply means the area on top minus the bottom area. So this is the top area minus what? The bottom area. So this is the condition that we are simply talking about. What is on top subtracts, because the region that is below is gonna be a negative. So how do we calculate? All right, let's calculate area 1. Let's not waste time, guys, because yes, calculating of the area, everything is there, the representative strip. So let's calculate area 1 from what? From 3 up to 5. Area 1 is limited. So area 1, this one is for x. It's limited. So that's the integral of y with respect to x from a to b, as we said. The limits 3 to what? From 3 to 5. What is limiting there? It's from 3 up to what? From 3 up to 5. Why? Remember, it's our what? Our f of x. So what is our f of x? This is our f of x. X is squared minus 6x plus what? Plus 5. So when you see two regions like that, I will advise you to separate your areas. Calculate them separately. This one on its own, another one on its own. So you're going to integrate, guys, as usual. Remember your integration. Add 1 here. That's to the exponent of what? Of 3 over 3. Minus 6 is already 1. So 1 plus 1, that's going to be 2. So over 2, this was going to cancel and give us what? A 3. So that's minus 3x squared. This is x squared here on our 3. So it's going to be minus 3 x squared. 5 is a constant. So integrate 5 with respect to x. That's 5x. Where we have got our limits taken from what? From 3 up to 5. So this is our condition. So you're going to substitute upper minus lower limit for calculating area 1. Area 1, it has its own limits. It has its own limit. Here we're not talking about the top area minus the bottom. No, we are talking about the limits as they are, as we are calculating this area 1. It has its limits from 3 to 5. So we're going to substitute these limits that we are given. This is our condition. All right. So let us substitute, guys. 5. So here, because of time, guys, it's going to be 5 in place of x to the exponent of 3 over 3 minus 3 times 5 is squared plus 5 into 5 like this. So this is our upper limit minus the lower limit. In place of x, we substitute the lower value, which is 3. So that's 3 to the exponent of 3 over 3 minus 3 into 3 squared plus 5 into 3 like this. So this is what you're going to have. So you're going to simplify this and obtain the first area. So let's just see this one. So the first part, let's put a fraction, 5 to the exponent of 3 over 3 minus 3. All right, so that's a minus there. You're going to have 3 into 5 squared. All right, plus 5 into 5. All right, plus 5 into a 5 like this. So that was going to give us, all right, minus 25 over 3. So this is minus 25 over 3 minus this one. We substitute in place of x now. It's what? In place of x now, that's a 3. So just going to put a 3 in place of x. Put a 3 here. In place of x here. In place of x, we put a 3. Okay, let's put x in place of 3 everywhere where we've got our x. We put a 3 as it is. So that was going to be negative 3. All right, negative 3. Remember here, it's just like I fixed my calculator, but that's a negative 3 like this. So this is it. You are going to combine these two and see that's negative 25 over a 3 like this. Negative 25 over 3 minus, what are we subtracting? A minus 3 like this. So it was going to give us a negative, as we can see, negative 16 over 3, or as a decimal, negative 5,333 like that. So you're going to get minus 5,333. That's a negative area, this one, because of what? Its region. So if you are using this formula that we're going to have the top area minus the bottom area, you use it as a negative as it is. Yes, we do understand that the magnitude of area is what? 5. The magnitude. Yes, it's giving us a negative there according to our calculations. But the magnitude there is what? It's 5. So the magnitude of area, magnitude, it's always whenever the word magnitude is, you use what? As a positive value. So the magnitude of this area is 5,33 square units. All right, this is just like the area is always positive, but as we have it on that region where it is found, with the region where it is found, it is carrying what? It is carrying a negative. So our A1 is a negative according to calculations. It's negative 5.33 square units according to calculations. Its magnitude is what? 5.3. This is the difference. Magnitude, you're talking about the positive value. So do not worry. You calculated the first one. What are we going to do? With the same situation, we're going to calculate the second area, this one, which is now taken from what? From 5 up to 7 now. From 5 up to 7. That's our area now. The second one is taken from 5 up to 7. So it means these limits we're going to change because we are working with what? 5 up to 7. So the limits we're going to change. So that is where I was using, say now it's going to be, because 5 is the same value. So it means we're going to have A2 as what? From where? From B up to C. The same value from B up to C. As we can use C, D, whatever that we had. The limits has changed here. The limits are the ones that has changed. From where to where? We're going to write it as it is. From 5 up to 7. So it means, guys, the integral part, the function is still the same. The only part that changed are the limits that you are now starting from 5 to what? From 5 to 7. Everything, guys, is still the same. So you're going to integrate the same way that we integrated. When you substitute your limits, that is where the difference is, because on these limits, we are now having what? 5 and 7. So our upper limit is going to be what? 7. So here, we're going to substitute a 7. Here, guys, I'm not going to redo this. We talked about this. Just going to substitute the previous case as it is. In place of what? That 5 that we had, now it's a 7. So this is 7 to the exponent of what? Of 3. 3 into 7, 5 into 7, our upper limit. Here, our lower limit is what? 5. 5 to the exponent of 3. This is 5. This is 5. All right. So that is what you're going to have here, guys. It's just a repetition of what we had. We're going to integrate. We substitute our limits as before. So that is it. Just like that. We are done. So let's substitute. This time is what? 7. All right. So that's 7 to the exponent of 3 over what? Over 3 like this. Minus 3 into 7 squared plus 5 into 7 like this. So this was going to give us 7 over 3. All right, so we are now simplifying this on its own. So that's 7 over 3 minus this. I want you to see that this one, guys, you calculated this one. When you substituted the limits before, this one, we calculated this one. This one, guys, we calculated this. That was the negative 25 over 3. It's only that I had removed that part, but that was the part that we calculated when we substituted the limits before. But anyways, you can just substitute because your calculator is there in case that you have forgotten. A 5 is there, a 5 here. So you'll see that we calculated this one. All right, my network. You see now. All right, let's just hope I'm going to win here. So that's a 5. That's a 5. So guys, you must subscribe, guys. You see what we go through. You're supposed to subscribe to make sure that everything also goes hand in hand. All right, no problem. It's not a problem, guys. As long as you are learning, this thing of telling people to subscribe is something else. So this is it. We calculated this one, negative 25 over what? Negative 25 over 3 like this. This is what you're having. So we calculated this one before. It's not a problem. You're just going to substitute your values in case that you are having a challenge. So you're going to combine 7 over 3 minus this. So it's going to be minus, what are we subtracting? Minus 25 over 3 like this. So this is what we're going to have. 32 over what? Over 3. So that's 32 over 3, which as a decimal, because we wrote the previous one as a decimal. So let us also have this one as a decimal, 10,667. So that is what we are going to have, square units or units squared. That's our second area. And as we can see, it is having a positive. The way that I've explained that, it is going to give you a positive, this one. Positive area. So you calculated your second area. It's already positive, that one. So its magnitude is that value. Remember when we talked about the magnitude. So our second area gave us 10,667 square units to 3 decimal places. That was our second area. So I'm saying that when you are using this formula, where you integrate and your answer is there as it is, you just obtained your answer having a negative and that one having a positive, you are going to use the concept that we use the top area minus the bottom because of that concept. So to calculate our total area from these integrals, we're just going to have our top area minus what? Minus the bottom. Because the bottom is carrying what? A negative. So it will be minus, minus. All right? In case that you have maintained those values. So it will be bottom area like that. Meaning to say our top area is area 2, which is A2 minus A1. So our A2, that's 10,667 minus what? Our first area, it is negative 5,333. According to our calculation, not the magnitude. We are talking about the value that you obtained in using those values that you calculated as they are. You are going to obtain your area this way. So it is simply 10,667, this one, 10 point, I don't trust, like if I fixed my calculator like that, normally it gives me the answers that are not the way that I want them to be like. So it's going to be negative 5,333 like this. So you're going to have this as your what? As your area 16. That's 16,00 like that, which is what we are talking about, 16 square units in terms of the total area. It's going to be 16 square units. This is what we have. But remember, as we are calculating, this is the magnitude of the area now. It's positive value, as you can see, it's magnitude there. Positive as it is, it will give you the magnitude at the end. There it was the value of area that we calculated as it is, the value of area that we calculated as it is. But let's say we are talking about the magnitude of these areas. As we can say, magnitude, it's always a positive. Whenever you have the word magnitude, you are talking about what? The positive value, the positive part only, the positive part only. So if you are working from the magnitude, it means our total area was going to be calculated by just the sum of the two. Area 1 plus area 2. You just need to add the magnitudes. This is the most important part. Add the what? The magnitudes of the areas. Add the magnitudes of the areas. You add them together. When you are dealing with the magnitude, it means we're not going to use this part of subtracting. Magnitude, you just have to combine it, guys. The magnitude is the positive value of the area. The magnitude is the positive value of whatever that you're calculating or whatever that you're dealing with, the positive value. So using that concept, you are going to have the same area, or we are going to have the total area calculated as A1 plus A2, which is the magnitude of area that we are talking about, the magnitude. This one. Let me present this way so that you understand each other. The magnitude of area 1 plus the magnitude of area 2. What is the magnitude there? The positive, when you talk about the magnitude, you ignore this negative. That's the magnitude. So it is what? 5,333 plus the magnitude of area 2, area 2, it was already positive. So it means that's our magnitude as it is like that. So you combine these two, still you are going to have the same answer as that one that we obtained previously, which is 16 square units. All right. Or you can just like 16 square units in short like that. So this is it. So like I said, guys, as for this part, I was expecting to finish everything in one class, but it seems like, oh, guys, there is a lot that I need to explain. There are some things that I need to add, add, add a lot. We need to add some, so like guys, we just need to add a lot of things. So with time and we'll see. So make sure that you become part of the family, Maison African Motives, by subscribing and also joining the membership so that all these guys can help us to give you more classes as you are preparing for the exams that are ahead of time, your preparations for your tests, your preparations for the exams, the introductions. So also just join the membership. I was even surprised, guys. We've got like people who are doing N4 and they're joining membership for N5. Like, guys, say I have joined membership for N5. I just want to support. Say this is good. I'm not saying do that, or I'm not saying do something like this to make me do this. But it is just like, what can we say? For us to have more of these guys, time frame, like the commitment on its own on this part, we just also need that to be also from you. As you are supporting us, we have more classes that are going to come to you guys, more of these classes. Yes. So let's join the membership so that we do not miss any of the other classes that you're going to have till we meet again.